All right, welcome back. So today we are going to be continuing the conversation of linear inequalities, except today we're going to be talking about solving systems of linear inequalities. Let's quickly think back to solving systems of equations. Essentially, when we are trying to solve systems of equations, let's say by graphing, we would graph one line, then we'd graph a second line, and we try to see, okay, this right here, this point of intersection is a solution. Right? That's essentially what we were doing when solving systems of equations. But now if we think back to last class, when we were talking about graphing linear inequalities, we would graph a line, and then we would determine whether or not we're shading under or above. So let's say this would be under. Well, if I want to graph another inequality, because we're talking about a system here, so a system would have two of them. Well, I would graph that inequality. Let's say it looked like so. And let's say for this separate one, let's actually put this over here to the left. Let's say for this separate one, when we determined we had to shade, we shaded up. And those are two separate linear inequalities. When we're talking about a system, we're going to be bringing them together. So really, all we're doing is we're just going to be dragging it together and seeing, hey, where is there an overlap in our shading? Because when we shade with linear inequalities, as we saw last class, we're talking about the all possible solutions. They're either under or above the line. So when we talk about graphing two linear inequalities, we're going to graph them kind of separately, but we're going to be looking for the overlap right here. Because this part shows I have solutions from my red shading and I have solutions from my blue shading, which is essentially what we're trying to do here when solving these systems of linear inequalities. But let's dive into more of a formal example. But this is the general idea of today's lesson. So you can graph a system of linear inequalities by combining the graphs of the inequalities. Let's say we have this system and it's y is less than or equal to 2x plus 3 and y is greater than negative x minus 6. We're going to graph each one separately just to visually show you what's happening here. When we graph each of them separately, this is what they look like. But now that we're talking about a system and we're saying, hey, these two linear inequalities are happening at the same time, what we're going to do is we're going to combine them together. And you can see that the solutions are going to be in that double shaded area. We essentially graph one linear inequality and shade. We graph the second linear inequality and shade. And we see, hey, where is the overlap? In linear equations, we tried to find that one point that gave true statements for both equations. In here, in linear inequalities now, we're trying to talk about what are the vast coordinate points that give us these true statements. And conceptually, that should kind of be logical because the shading of one, the first system again is down here. So that would be in red. It would look something like this. And the shading of the second linear inequality, let's say it's in green, that would look right here. And as you can tell, we have that overlap. We're saying in the overlap spot will represent solutions to the first linear inequality in red shading and the second linear inequality in green shading. And two possible ordered pairs that make these solutions true are 3, 4 and 5, -2. There is an infinite amount of these ordered pairs, which is such a beautiful thing when you think about it. Sometimes we're going to have to be asked, hey, what is one possible coordinate point? What are two possible coordinate points? And all we have to do is look in that overlapped spot. And that's how we solve systems of linear inequalities. We are not going to use substitution. We are not going to use elimination. We are just going to be graphing to see the overlap of those two linear inequalities. Awesome. With this in mind, please work on problems 1 through 4 on the guided notes and resume when you're ready to move on. All right, so systems of equations with parallel lines we know has no solution because parallel lines never intersect and we're trying to find the point of intersection. Well, parallel lines in a system of inequalities, those might have solutions, and there's really 3 cases of what we're going to be going through. So given here are 3 different systems, and if you notice, they all are going to be parallel because they all have the same slope within each system. In the first system, we have a slope of 1. In the second system, we have a slope of 2. In the third system, we have a slope of -3. What I want us to be able to identify here is we have opposite signs in the first one. We have a greater than or equal to and a greater than in this second system. And then again, we have opposite facing inequality signs. So let's see what might happen when it comes to these 3. Actually, jot that below. What do you think is going to happen when we have these opposite signs or even the same signs with these parallel lines? All right, so let's see what actually happens. If we look at this first system, solutions are going to be in the double shaded area again, and those are going to happen between the parallel lines. This is going to happen between these parallel lines. One of the inequalities is shading below, the other is shading above. So we're going to have that set in between those parallel lines. That's going to be the solution set, which is, again, if you can't tell, because it is a little bit tough to see with these grays, it's going to be in between here. The second set, this is when we have a greater than or equal to and a greater than. You're going to notice that solutions are in this shaded area, and that's going to be on one side of the line because both of these lines, or these linear inequalities, I should say, have shading going on above the line. So your solution is going to be like such. It's going to be above one of the lines. Because they're parallel, they never intersect, but both of those linear inequalities we're shading above. So we're going to look for that overlap. And it should make sense that it's not going to be in between because, again, we're shading above that solid line. So underneath the solid line doesn't have any solutions. So the solution to the system will be above that line. And lastly, let's look in blue. There's going to be no overlapping areas here. So this is going to be what is called a no solution because there is no overlapping happening. And the reason is if we look at those y-intercepts, we're saying, hey, we're going to be shading above 5 and below -3. Well, can you think of a number that's above 5 and less than -3? No, which is why we get a no solution. Compare that to the first set of linear inequalities. Looking at those y-intercepts, we have a +4. So we're saying y is less than 4 and y is greater than -2. Can you think of a y value that's smaller than 4 but bigger than -2? Yeah, 0, 1, 2, 3, 3.5. Right? There's a lot of those, which is why it's going to be the inside of those 2 linear inequalities compared to the third system on the right-hand side shaded with that blue. We can't think of a y value that's greater than 5 but less than -3, which is why that ends up with a no solution, just like we would with a 1 variable linear inequality. Awesome job, kiddos. Please work on problems 5 through 7 on the guided notes. Great job today. You should be really proud of yourself. You're doing really well. If you have any questions, please jot them below. But other than that, kiddos, I will talk to you soon. Bye.